If you happen to be watching this video, it's on page 14 of your work packet. And we're going to start by looking at the chemical reaction and noticing it is balanced. So we're going to use those coefficients to tell us how many molecules to write. And I'm just going to put a line here at random. We looked at this reaction in class, and just for the sake of the video, I got to get this here and go. That's burning propane right there. That's this reaction. It's exothermic, which is going to give us a heads up that this reaction should come up with a negative delta H. So I'm going to write CH3 here, but I'm going to write the structural formula that's provided up above. It's provided up above, a little higher on this page, I hope. I'm going to double check and make sure. So there are lots of bonds that have to be broken to make this into the activation complex. So there's the structural formula right there for propane. It isn't labeled, is it? Okay, but you'd figure that out. And then there are five, count them, five oxygen, and that's O2, and that has a double bond. And I'm just going to put a coefficient in front of that to save some space here this morning. So let's add up all of those. And I don't have a list of my bond energies. I'm going to grab that real quick. You have it just inside the front cover. Just inside that green front cover, you have bond energies. And so the bond energy we have hydrogen and carbon single bonds. We have carbon to carbon single bonds. And we have oxygen to oxygen double bonds. Are there any other bonds? Let's see how many of those we have. I'm going to highlight them on my screen. You guys are, let's see. Did I get a green there? Yeah. So here's 1, 2, 3, 4, 5, 6, 7, 8 of this kind of bond. So we're going to label that with an 8. And we're going to go 8 moles of this times hydrogen-carbon single bond. You guys correct me if I make a mistake. That's 411 kilojoules per mole. And for those of you watching in the comfort of your home, that's from this table on the inside front cover. Okay, so 8 times 411. We have how many of the carbon-carbon single bonds? That's this bond right here that I'm highlighting in blue. So it appears there are sorry. I want that pen, but I want it just a little fatter, please. So there are 3 of those. So that means we have 3 moles of those bonds. And we're going to multiply that by carbon-carbon single bond, 346 kilojoules. And the oxygen-oxygen single bond, we have 5 of those, right? Because I have this coefficient. Now let's use, where's it? There's a color we can use. Thank you. See? That's why we have you guys watching carefully to see if I make any mistakes. And for those of you watching the video, what they just noticed was that there's actually only 2 of those blue bonds. So this is only a 2. Everything else going okay at the moment? Anything else need changed? Oxygen, oxygen, double bond, 494. So I gave all you guys, y'all calculators, but I didn't grab one. Let me grab one. Be sure you're checking my math here, because this is where we could easily make some kind of mistake. When you're taking this for a test or a worksheet, when you're working on a worksheet, you have multiple people around you kind of checking your work. When you're working on a test, it's a good idea to do these multiple times. Did you guys get 3,288 kilojoules? My calculator died. What's with that? Right in the middle of a calculation. It just stopped working. So we're going to find the sum of those. Did you guys come up with 6,450? So I must be right so far. Everybody in the classroom here agrees with my answer. That's amazing. Okay, so that, we're supposed to label that as the activation energy. So that is how much energy it took to break apart all of these bonds that we have covered. So we're going to label that as activation energy. And we're going to call it 6,450 kilojoules. Now, I'm going to switch all of my colors to red. Come on, red. Because I'm going to now go down this direction. We already discussed the idea that it has to be exothermic because it made a big flame. So now the thing we're going to do is draw on all the products, the things that this chemical reaction produces. And so that's going to be CO2. So there is, up above, there is a structural formula. And notice we're going to draw 3 of these because this coefficient right here tells us there are 3 of those. And we're going to draw 4 waters because this coefficient tells us there are 4 waters. That's hydrogen, oxygen, hydrogen, hydrogen, oxygen, hydrogen, 4 times. Wow, I didn't break into my H2O song today. There we go. So, but really here, the math may be easier because we only have 2 kinds of bonds. We only have 2 kinds of bonds. The first kind of bond is we have this bond, and this is kind of the special one we have to notice on our list. There are 6 of them, 6 oxygen carbon double bonds in, don't forget it's in carbon dioxide. So that's going to be 6 times 799. You remember that you use a different number there, and I'm going to use a negative number. I'm going to go back and put in my units 6 moles, and it's negative 799 kilojoules per mole and the other bond we are dealing with is this one, and there are 1, 2, 3, 4, 5, 6, 7, 8. Am I doing okay so far? There's going to be 8 of that kind of bond. There are 8 moles of the hydrogen-oxygen single bond. There it is in the second column, just below the middle of the second column on your sheet. 460, I've lost it. There it is, 464. And that's going to be a negative number because we're putting them back together. And of course, I'm being careful with my units. You should be too. What does that equal? So, let's see if I can find a calculator that is working. 6 times negative 4794 kilojoules. $3,712. So we're going to sum those together. The sum is 3,712 plus 4794. So now is that moment. Is this negative number going to give us a negative change in enthalpy as we predicted? So what is this change in enthalpy thing right here? I'm going to switch to purple for that. Purple, because it's Friday today. If you happen to be with us in person, it's Friday and everybody's wearing... Yeah, out here in the audience, it's a sea of purple. I don't see anyone wearing anything other than purple because they're celebrating Friday. I have my tongue lodged deeply in my cheek to say that. So the change in enthalpy is going to be a negative number when we just put these together. Negative. Is this what you guys are all getting? Did we come down to the same answer? That is the change in enthalpy. It's a negative number, so yes, this tells us it is exothermic. And the system, what else are we supposed to answer up here? Is energy lost or gained? Energy lost. So, is there anything I missed? Did we get the entire answer in? I'm going to kind of zoom back here. If you guys ever need to go back and look at these videos, I try to leave the video on a kind of a picture of most of the problem. Did we get it right? Everybody's agreeing? Yes. So, that's supposed to come up and let me stop this video. There's the stop button.